For this week's experiment, we are going to be looking at phase changes and how they can occur rapidly if properly provoked. We're going to be taking advantage of water by cooling it to the point of a phase change and then using different stimuli to force that phase change. So for this experiment, you're going to need 3 purified waters, and it's important that they're purified because that means they're going to have no impurities to them, so it wouldn't affect our experiment. So I put them in the freezer for about 2 hours, and they're not frozen yet, but they're definitely cold. And then a cup, and then a bowl with ice in it. So I'm going to go ahead and do the experiments, and then I'll go ahead and explain them afterwards. So we're going to take one of our water bottles and we're going to put a force into it. So let me do that. It is supposed to crystallize. I can try doing it on this one, see if that happens. Kind of did a little bit. There's a little bit of ice that formed in that. This one actually kind of did a little bit more, but what's supposed to happen is that force is actually supposed to create the water bottle to freeze. The next one is we're gonna take one of the water bottles and we're gonna pour it into a cup and then put an ice cube directly in the middle. And again, a little bit formed here on the outside of the ice cube. I'm trying to turn it so you can see it. But that one again is supposed to create a huge bowl of ice as well. And then for our third one, stimuli, we're gonna pour the water over ice. Well, there is ice inside of this, as you can see. I did try to tap this one, so maybe that's why it formed that ice cube. But so what is supposed to happen is when we pour these water bottles that were supposed to be to the point of a phase change, they were supposed to create more of an ice sculpture here. This was supposed to be all water, and then when I pressed on the ice cube, on the water, it was supposed to create a huge water bottle full of ice. Unfortunately, it didn't happen, but I'll explain why that does happen. That's because let's understand what a phase change is. That's when a matter like a water or a liquid changes from one state, which can be a liquid form, a gas form, a plasma form, or a solid form, and it changes into another form. So it can go from a liquid to a solid, which is what ice cubes are, or a solid to a liquid when you melt water. And these phase changes all occur because heat energy is either added to them or subtracted to them. So freezing phase is the one where liquid turns into a solid when its temperature is lowered to its freezing point. Water has a freezing point of 32 degrees Fahrenheit. And so what understand how freezing works is molecules of water or anything are always moving. And as temperature goes up, they move faster. And when temperature falls, they move slower. So when water freezes, it needs a nucleus in order to form solid crystals and become ice. So water typically is full of particles and impurities, which have no problem reversing the process of crystallization. However, purified water does not have those impurities, which is why we were using purified water so that it would occur. So freezing happens when a molecule of a liquid gets so cold that it slows down enough. It slows down the moving of those particles enough so that they hook onto each other, and they form a solid crystal. which as you can see is this right here. So unlike other liquids, water, when it freezes in ice, it expands, and it's actually less dense in water, so which is why ice cubes float. So when liquid contracts, so as it cools, it contracts, because the molecules are moving slower. They are less able to overcome the attractive intermolecular forces, which draw them closer together. And then the freezing temp is reached and the substance solidifies. And that creates that crystalline solids. And that's why they're usually tightly packed, is because there's no other forces acting on them. So what we were supposed to see when we poured the water over the ice cubes, it was supposed to be nucleation, that occurs when molecules in water clumps together to form a crystalline nucleus. And then once the molecules are formed, they can latch on to the nucleus. So it was supposed to just kind of latch on, create even a bigger structure. And the way that water forms these ice cubes is by hydrogen bonds. And they get stronger as the temperature gets lower, because there's less heat that's being added to them to shake the bonds out of their position. And therefore, when they're not moving as much, they're able to actually bond better, and they force the crystalline structure to happen. And then, so another stimuli to trigger that is to send like that. When we hit it, it was supposed to be like a shock wave, which adds that energy to be released and create those stronger bonds. It releases that extra amount of heat that was keeping them from forming that crystal. And that is why, or how, phase changes can occur rapidly if properly provoked.